Look up at a clear night sky and it feels obvious, right? Stars, galaxies, and then nothing. Black, empty space stretching between them. That's the assumption almost everyone grows up with. Galaxies are the stuff, and everything in between is just void. Empty. Nothing going on. Here's the thing. That assumption is wrong. Not a little wrong. Fundamentally wrong. The space between galaxies isn't truly empty. It's filled with incredibly thin gas, threaded through a vast cosmic web and influenced by things we still can't directly see. In fact, most of what makes up the universe isn't even in the galaxies at all. So today, we're heading into the gaps, the places between the lights, to find out what's actually hiding in the dark. Let's get into it. Let's start with the most direct answer. There's actual matter out there, just spread incredibly thin. Scientists call it the intergalactic medium, mostly hydrogen and helium gas left over from the early universe, drifting in the space between galaxies. It's not glowing like a star, it's not dense enough to form anything, but it's real, physical matter. For decades, this gas was almost impossible to detect directly because it's so spread out. We're talking about just a few atoms per cubic meter in some regions. That's emptier than the best vacuum humans have ever created in a lab. But over cosmic distances, almost nothing adds up to a lot. And here's where it gets interesting. Astronomers have found that a huge chunk of this gas isn't just cold and quiet. Observations suggest large portions of it were heated to extreme temperatures, sometimes referred to as the warm-hot intergalactic medium, or WHIM for short. Some models suggest this hot, thin gas may account for a significant share of the universe's ordinary, normal matter, the kind made of atoms, not the exotic stuff we'll get to in a minute. So step 1, the dark isn't empty, it's gas. Just gas so thin it's basically invisible. Now here's where things get genuinely wild. That gas between galaxies isn't just floating around randomly either. When astronomers map the large-scale structure of the universe, a very specific pattern shows up, over and over, at every scale. Galaxies aren't scattered evenly. They're arranged in long, thread-like structures called filaments, connected at massive junctions called nodes, with huge, mostly empty regions called voids in between. Put it all together, and it looks like a web. Astronomers actually call it the cosmic web. Picture a sponge or a spider web stretched across 3 dimensions, except each strand is made of galaxies, gas, and matter, and each strand can be hundreds of millions of light-years long. This isn't a loose metaphor either. This structure has been mapped using large galaxy surveys, and it lines up closely with computer simulations of how the universe evolved. Gravity slowly pulled matter into these thread-like patterns over billions of years, starting from tiny fluctuations in the very early universe. So that darkness between galaxies, a lot of it is actually connective tissue. Filaments linking galaxy to galaxy, cluster to cluster, across the entire observable universe. Okay, but what about the actual empty parts? The voids. These are real too, and they're staggering in scale. Cosmic voids can stretch across hundreds of millions of light-years, containing very few galaxies compared to the dense filaments surrounding them. One of the most famous examples is the Buddha's Void, sometimes nicknamed the Great Nothing, which spans roughly 250 million light-years. If our own galaxy sat in the middle of it, we likely wouldn't have known other galaxies existed until relatively recently in our technological history. That's how sparse it is out there. But even voids aren't completely empty. They still contain some galaxies, some gas, and, based on current models, likely still contain dark matter, just at much lower density than the filaments around them. So the darkness has layers, dense filaments, sparse voids, and every level in between. Now we get to the part that changes everything. When scientists calculate how much visible matter, stars, gas, galaxies, actually exists in the universe, the numbers don't add up. Galaxies rotate, and clusters of galaxies move in ways that shouldn't be possible if visible matter was all there was. There isn't enough gravity from what we can see to hold these structures together the way they clearly are held together. The leading explanation is dark matter, a form of matter that doesn't emit, absorb, or reflect light, which is why we can't see it directly. We only detect it through its gravitational effects on the things we can see. And based on current models, dark matter isn't just scattered evenly through space. Many scientists believe it forms the actual underlying scaffolding of the cosmic web itself, an invisible structure that ordinary matter, gas, and galaxies fell into and clustered around over billions of years. In other words, the visible cosmic web we can map with telescopes might just be tracing the outline of a much bigger, invisible one. To be clear, dark matter itself has never been directly detected in a lab. It remains one of the biggest open questions in physics. But the gravitational evidence for something unseen shaping the universe is about as strong and consistent as evidence gets in cosmology. And just when you think you've got a handle on the invisible stuff, there's another layer. In the late 1990s, astronomers studying distant exploding stars called supernovae discovered something that shocked the entire field. The universe's expansion isn't just continuing, it's accelerating. That shouldn't happen if gravity were the only major force at play. Gravity should be slowing the expansion down over time, pulling everything back together. Instead, galaxies are speeding away from each other faster and faster. Scientists gave the cause of this a name: dark energy. And here's the genuinely humbling part. Current estimates suggest dark energy makes up roughly 68% of the total energy content of the universe. Dark matter accounts for around 27%. That means all the stars, planets, galaxies, and gas we can actually see and study, that's roughly 5% of everything that exists. We are, quite literally, studying the tiny visible fraction of a universe that's overwhelmingly made of things we can't directly see. What dark energy actually is remains one of the biggest unanswered questions in modern physics. Some models treat it as a property of space itself. Others propose it could relate to modifications of gravity on the largest scales. Nobody has a confirmed answer yet, and that's honestly one of the most exciting open frontiers in science right now. So next time you look at the dark gaps between galaxies, remember, that's not nothing. It's thin gas, heated by the history of the universe and detectable through the faint signals it leaves behind. It's invisible filaments of dark matter, quietly holding entire galaxy clusters together. It's dark energy, relentlessly pushing everything apart, faster with every passing year. The stars are just the part we can see. The real story of the universe is mostly happening in the dark. Kind of insane to sit with, honestly. We've mapped the visible universe in incredible detail, and yet the ordinary matter we're made of accounts for only about 5% of the cosmic energy budget. If you want to keep exploring what's hiding in the space between the lights, hit subscribe to Deep Space Files, because out here, the darkness is where the real story lives.